Welcome back to M2. Today we're looking at non-uniform composite laminas and frameworks. This is the last video in this particular unit. Now this video really is just going to be an example and a few questions, as it's really kind of tying together a lot of the skills that we've built up over the last few videos. I'm putting them all together into these types of questions. So let's get straight into looking at the first example. So here we have a nice example to get us started. Straightforward shape. We've got a rectangle. This portion is going to be folded over into here, which will create a square. But this square will have a double thickness here. So if I just do a very quick sketch, we've now got a shape that is, a square. So A, E, F and D. And this is going to be 4 centimeters by 4 centimeters. But kind of coming down this middle here, which will be 2 centimeters, this is double thickness. Okay, so I'll just give it a little bit of shading for you there. This part is double thickness, so it's going to be double the density. And that's something I need to make sure I take into account when I'm solving this particular problem. So looking at the center of mass of the two rectangles that make up this square. So we've got two rectangles, center of mass here and center of mass here. So we're going, again, now in this particular one, I'm going to be ended up to take D as my origin. So kind of taking D as origin. And normally say that DF lies on the x-axis, AD lies on the y-axis, but I'm just going to get straight into it. So the center of mass for this one is going to be 1 across 2 up, isn't it? And in this shape, it's going to be 3 across 2 up. Now, I don't have too much to worry about in terms of the y value, as they're the same, so they'll stay the same, but I'll do it as if they're different, just so that you guys can see how you approach this. So looking at the area of this first one, okay, so I mean essentially if I just pop in the letters, B would now be here and C would be here because it was folded over, wasn't it? So if I'm looking at rectangle ABCD now, as in the small one, this new one, it has an area of 8, 2 times 4, yeah, and a center which is 1, 2. Looking at my second rectangle, which is BCFE here, it has also an area of 8, however it's double the thickness, so double the density. So instead of an area of 8, we think of it as an area of 16, and it has center 3, 2. And then my total area here is 24, and obviously we're looking for X bar and Y bar. Now the 24 obviously should match up with the 16 and the 8, but it should also really match up with the original here, which is my 4 times 6, 24. Now from this point on, it's the same process as we've done a million times. And we've got 7/3 for our X and 2 for our Y. 2 is obviously what we were expecting, as they're obviously the same here. Sometimes I would just normally quite often skip the Y, I can just state it, but I've just done it both there. So, we just need to finish the question off, in terms of, where we're going. So obviously X bar is 7/3. Y, as we said, was 2. So these are from D. So, it's 7/3 from AD, and 2 from DF. Okay, as we went from that point D there. I put from AD, you know, I could have also put, you know, right, you know, to the right or up, you know, and just filled it out a little bit more. Now, in this example, we're looking at a framework, and it gives us the masses of each of them. So A to B, you know, is 2m, B to C is 3m, C to D is m, and D to A is 5m. So those are my masses, and then I need to find the coordinates of the centre of mass of the framework. So remember, when you're doing the framework, you're just looking at that centre point within each line. So from A to B, you know, we're going from -1 to 7. It's essentially, it's 8 across. So, you know, we're looking at 4 across from that -1. So that's going to be at 3. So, you know, that first one is going to be 2m multiplied by 3 minus 1. And looking at my second one, we're going to get 6, 1 as our centre there. And my third will be 4, 4. And my final one will be 1, 2. Remember, to find the midpoints, I can just add my coordinates and divide them by 2. Very straightforward. And my total mass here, 5, 6, 9, 11. And of course, X bar, Y bar. Now, as in previous questions, M's and everything, so let's divide through by M to make my life just a little simpler. And then same kind of process as every other question. Therefore, centre of mass lies at 3 and 15 over 11. Now, I'll give you a few to try yourself, and as always, I'll pop the answers at the end of the video. Don't forget to hit that subscribe button if you haven't done so already. So in this one we have a lamina made of a square, A, B, C, D, and C's being folded into the centre. So let's just get a rough kind of sketch of this. C's being folded into the centre. So kind of something like this now, where this is 16 centimetres. So we're looking at 8 and 8. There, we're also looking at this being 8, you know, down into the centre. So that certainly helps me out. So I've got A, B, C and D. Okay, nice and easy. And then let's add in an E and an F for that triangle. So what I want to do here is essentially split this up into 3 shapes: rectangle, square, triangle. Okay, now the rectangle, so let's first start by taking A as the origin. And then this first rectangle, which I've A, B, C, D, E, F, let's add a G in there. So kind of A, D, E, G. That's going to be 8 by 16. So 128, and it's going to be 4 cross 8 up. Pretty big there. Now, second one, which is a square, CFDG. So here, CFDG, you know, this is going to be 8 by 8, so 64. And it's going to be, in terms of its centre, we've got 8 and another 4, so that's 12 and 4. So 12 across, 4 up. And then finally we've got our triangle, which is CFE or CEF here. And we got, it's 8 by 8, so 64 divided by 2, so 32. In terms of its area, and then we need to think about its coordinates here. So I'm just going to do that down in a different color, kind of just to stand out on the side. So I'll do this in green. So if we think of where C is, so currently C is 8 across, 8 up. So that's 8 across, I'm just going to put that there, like that, 8 up. If I look at where E is here, that's 8 across, 16 up. So it's 8 and 16. And then if I look at where F is, that's 16 across, 8 up. So 16 across, 8 up. And I want to divide these by 3. So both of them are going to give me 32 over 3 as my centre coordinate there. So this means this is 32 over 3 for both of these. Now, just going back to this, the triangle had an area of 32, but of course it's actually double thickness, isn't it? So I mustn't make that mistake. So it's not going to be 32, it's going to be 64. Okay, so just checking that because it is double thickness. Now this should total 256 x and y bar. And you know, I could check that because when I added 128, 64 and 32, it didn't total my 16 by 16, which is my original area here. So when this is double thickness, it should still be the same area. And that should, you know, make kind of logical sense. Now you know what to do from here. And so the centre of mass of this lamina is at 23 over 3, 23 over 3 from A. Next one, we've got a rectangle. AB is 10 and BC is 6. And we've got the lamina folded over so that the side AD lies along AB. So we kind of folding it so that this side will end up along this side. So if I think about my kind of rectangle here, when AD gets folded along kind of AB, it's going to go about 6 centimeters along, isn't it? And then this is going to end up with a triangular edge here. So that's going to be 6 centimeters along, leaving me 4 centimeters left there. So that's going to be C, and that's obviously going to be my D. So I'm going to add in a new letter E there, just to go ahead with this. Okay, so just imagine visualizing it. You folded it over, and now we have a triangle which is double thickness and a rectangle of single thickness. So if I think about the rectangle first, that's 6, so it's 4 by 6, 24. And of course, before I even start, I really need to pick a point. So let's go take A as origin here. So if I'm thinking of from A, we're going to go 6, 7, 8 across, and then we're going to go 3 down. So this is going to be 8, negative 3. Now with my triangle, it's 6 by 6, which is 36, divided by 2 is 18. However, it is double thickness, so times in back by 2 takes me back up to the 36. Now in terms of that one's centre, I need to look at my coordinates. So, A is the coordinate 0, 0. D is the coordinate 6, 0. And E is going to be the coordinate 6, minus 6. So I need to total up my x's here. So 0 plus 6 over 3. And then we've got 0 plus 0 plus a negative 6 over 3. So 12 over 3 is 4, and 6 over 3, sorry, negative 6 over 3 is negative 2. So here we have 4 and negative 2. And then my total area should be 60. 10 by 6. Check it, 36 plus 24 is 60. And of course, X bar and Y bar. Once I've done that initial setup, the rest of the question is very straightforward. Now, we've got the same kind of rectangle here, 10 by 6. But this time, before we start looking at how it's suspended, we can see that D is folded so it lies exactly on top of B. So D goes to here. Now it's a rectangle, so it's not going to fold nicely. We're going to have a bit sticking out of kind of either end. So let's just try and get that kind of rough idea of what it looks like. So I'm going to think of from B first. So we're going to get a bit here. It's going to be going across. We've got a diagonal. That should be kind of in line with this. Something like that kind of thing, where we'll also get this diagonal here. So what I've ended up with is this part here, this triangular part is double thickness. This bit is single, this bit is single. Not an easy thing to kind of visualize. I've actually done it cheating a little bit because I've folded a piece of paper myself, but yeah, not the most ideal thing to do here. Now, we know that this was 6 here, but we also know that this was 6 because this is my AD, isn't it? So this is also 6. So we got, B to C, but D is also there and A is there. That's kind of what we've ended up with. And then in terms of our other ones, we can safely say anyway that this length plus this little length will equal 10, or equally, this length plus the rest of it here would equal 10. So we want to kind of think about that there. So, like this, if I call this X, and I can call this, for example, Y, this X plus Y must equal 10. So we know that for sure. And here's about kind of using a bit of Pythagoras. So if I think of this triangle here, as we know this one's right angled. Okay, this is right angled as well, isn't it? Because that's obviously a corner. But you can see it nice and clearly here. So looking at this triangle, this is kind of what we are looking at right now. And what I want to do is I want to replace that Y. So Y is the same as 10 minus X. So I go down to my triangle and change that for a 10 minus X. And now I'll use Pythagoras. So X squared must be equal to 6 squared plus 10 minus X squared. So we get X squared equals 36 plus 100 minus 20x plus x squared. Now that's going to be nice because I can take away x squared, so these are going to go, and we've got 20x, which I'll take to this side, is 136. So therefore x is 6.8 centimeters. Also, if I look at my 10 minus x, that side now is going to be 3.2 centimeters. So I can pop those values onto my diagram now, can't I? So let's rub out the kind of x and y values. So we got, this is 3.2 and this one's 6.8, and this is 3.2 and this is 6.8. So now we've got a load of values on our diagram that should make our life a little bit easier. Now, what we need to do now is to be able to find the center of mass of each of these three triangles. So if I start off, let's add in a few extra letters. We got A, B, C, and D. Let's pop in an E and an F in there. So let's start with this triangle F, A. I'm going to do it as B. Now actually what I'm also going to say here is take C as origin. Okay, just because I think, you know, it's a nice corner point. There's nothing, everything's now either to the left or above it. So it should make our life a little bit easier. So first thing I want to do is find like the actual coordinates of B, A, and F. B is easy. It's going to be 0 across 6 up. Nothing difficult about that. As is F, will be minus 6.86 because we're just going across 6.8 and then up 6. A is obviously the one that's a little bit more difficult. As to find A, we're going to need to know essentially this height and this kind of position here. So it's like a triangle. So we know this, and we can work out this angle here, which I'm going to call theta, can't we? Because we have the larger triangle already. So if I use, you know, the 6.8 and the 6, or, you know, the 6.8, the 3.2, doesn't really matter here. But let's go with the 6.8, which is all the way across. So we've got cos theta is adjacent over hypotenuse. And that gives me 28.1 degrees to 3 significant figures. Of course, I'm going to use the full value though in the calculator. Now I can use that to work out what this missing value is here. Because I've got an angle, now I've got a new right angle triangle. You know, now I'm switching to this triangle, you know, with a 28.1. So again, it's cos 28.1, and it is, this time the question mark is the adjacent one, isn't it? And 6 is the hypotenuse. And that gives me 90 over 17, which is approximately 5.29 or 5.3. Okay, so I can say now that the coordinate A is that minus 5.3. Obviously we'll use the full value, but I also need to find the vertical value there, which is this one. So again, I'm going to use this on the 6, so we can use sine for that. So sine 28.1 is opposite, which is what we're trying to find, over the hypotenuse. And that gives me 48 over 17, which is approximately 2.8. So if you think of the coordinates of A, it's that bit there is 2.8, but it's also gone up 6. So it's, 6 plus the 2.8, so it's 8.8 roughly. We'll again use the full values there. So let's make a little note of that. So A is minus 90 over 17. And add in the 6, we get 150 over 17 there. So we worked out A, which is, the most awkward one to work out. We've got F and we've got B. So now we can find the center of mass of this first triangle. So first triangle now, adding up my x values, we've got 0 plus minus 6.8 plus minus 90 over 17. And then we've got 6 plus 6 plus the 150 over 17. And of course, each of those are divided by 3. And that gives me minus 1028 over 255. I'm going to put the fractions down initially so I can use them, but I will put as a, as a decimal. This will be approximately minus 4.03. And the second one is 118 over 17, which as a decimal is roughly 6.9 or 6.94 there. And that's of course A, B, F. Wow, pain in the neck that, but anyway, let's look at the area of ABF. Now it's a right angle triangle, the right angle at A. So we got 6 times 3.2 over 2. So that gives me 3 times 3.2, so 9.6 centimeters squared there. So now we've got, for A, we've got its, for that first triangle, we've got its area and we've got its center of mass. Now let's move on to the other similarly sized triangle. So let's do BCE. Okay, because that's going to have the same area. Do this one in purple here. So we've got triangle, looks like this. We can say the area is that 9.6 centimeters squared there. That is the same kind of triangle. And we want to find the center of this one. Coordinates are much easier. So going from C, we get C's coordinates are 0, 0. E's coordinates are minus 3.20. And B's coordinates are 0, 6. So looking at this, we got 0 plus my minus 3.2 for my x's here. And then we got 0 plus 6 for my y's. That gives me minus 16 over 15 and 2 there. Okay, so that's this triangle BCE. And, as an approximate, we've got minus 1.07 and 2. Now, with true triangles down, we've got this third triangle left to do. And I'm kind of running out of colours. So, let's do it. So, we've got F, E, B, it's 6.8 and 6.8. Not that that really matters, but let's look at the coordinates. So E, we know that's easy, isn't it? Minus 3.20. B, oh, that's easy, 0, 6. And F, oh, that's pretty easy as well, isn't it? Minus 6.86. Oh, so this is a lovely easy one to do. So really it was only that first triangle that was a bit more challenging. So looking at my x's, so minus 6.8 plus 0 plus minus 3.2 over 3. And looking at my y's, we've got 6 plus 6 plus 0 over 3. So that is going to give me minus 10 over 3 for the x's and 4 for the y's. And that is, of course, triangle BEF there. Now we also need the area of BEF, don't we? And the easiest way to do this is using the sine formula, you know, half AB sine C, if you remember that one. Because we've got two sides, and then we can find the angle in between. So we'd already found this angle, which was 28.1, which means, you know, either way we look at it, you know, this is at 90 degrees. So this angle, FBE, is 90 minus our theta from earlier. So 90 minus that 28.1. And that will give me 61.9 degrees, which obviously I will use the full value of. So we got half times 6.8 times 6.8 times sine 61.9. And that gives me 20.4 centimeters squared. And double checking all my areas, 20.4 plus 9.6 plus 9.6 plus a second 20.4, because that one's obviously double folded over, isn't it? That totals the 60, which is what I would have had in the very beginning. Anyway, now we can finally work out the centre of mass. So in the order I did them, we got 9.6 and minus 1028 over 255, and the y was 118 over 17, plus 9.6, this was minus 16 over 15 and 2, plus, now we've got 20.4 times 2, because it's twice the area, and it's minus 10 over 3 and 4. And of course it's going to equal 60 x bar y bar. Now with this one, I will just save a little bit of time and jump straight in with the multiplied out answers, just because it's a bit awkward with all these numbers. So my first value here is minus 262 over 85, which I'm just going to write down ready is approximately minus 3.08. And the y is 1764 over 425, which is approximately 4.15 there. Both of these are the three significant figures. And that's been a huge amount of work, yet the question is not finished, is it? We've now got to work out the angle that the vertical makes with AD as it's suspended freely from A. So this is what we've got now. I've just drawn roughly where G is and a straight line through G and A, as that is where it's suspended from. Just kind of turning it around to have a good look. So we've got something like this. Yeah. So approximately, you know, it's not perfect. This is the angle I want to find. I'm going to call it alpha, as I used theta earlier. And, you know, let's look at the points. We know point A, we know point G, we know point D. So let's look at that as a triangle first. Okay, A, D, and G. Okay, so G obviously we've just found. D we know is our 0, 6, wasn't it? We actually know the distance AD is 6, don't we? That's alpha. Can't really see a really straightforward way of doing this because we're not going to have a right angle triangle, are we? So I think, and you know, if you guys let me know in the comments if you find a better way, maybe it's quicker, but I think I'm going to work out the distance AG and the distance of GD. Okay, as we know all of those points, don't we? We know G, which I'll pop down here as our minus 262 over 85 and 1764 over 255. Sorry, that's not a 255 on the bottom, that's 425, isn't it? Because A is minus 1028 over 255, that's what I'm thinking of, and 118 over 17. So what I'm going to do here is use, you know, essentially a bit of Pythagoras to work out these distances and these distances using the coordinates. So AG, obviously AD we know, AG is going to be the square root, and it's going to be the difference in y squared, the difference in x squared. So I'm just going to label them because I don't really want to have to write all of these things out. So I'm going to call this x1, y1, x2, y2, x3, y3. So when I'm doing A to G, I just want the difference in the x's squared plus the differences in the y's squared and then square rooted. So that's what I'm doing in my calculator. And this first one's going to give me 2.95 to 3 significant figures. I'm just going to store that in my calculator as A. I'm just popping that there as a reminder. And then GD, again, we're going to do this very much the same way. So, you know, in this one, we are looking at just doing, say, x3 minus x2 squared plus y3 minus y2 squared. So all I'm doing is the difference in x's squared and the difference in y's squared. And this one gives me 3.59, again to 3 significant figures. And I'm going to store that in my calculator as B, so it's easy to find. Now I'm just going to use the cosine rule. And let's change my pen back to black. So we want to find, you know, cos A, cos alpha. And that will be, you know, my AD squared plus AG squared minus GD squared over 2 AD AG. And that gives me 26.1 degrees to 3 significant figures. Now, this one's a very long question. Let me know in the comments if you did it a different way. And also to double check my answer. And, you know, the question I got this from, there's actually 2 different answers and they're both different to mine. And I know that at least one of them's wrong because the wrong center of gravity. But yeah, so let me know with this one. It was a tricky one, just as I've gone from page to page, as I've gone through this. Let me know if you spot a little mistake that I might have made. Method is definitely right, but just let me know if I've made a little calculation error anywhere. Now in this one we've got a framework, 3 pieces of uniform wire, same material. The wire used to make BC and AC, so B to C and A to C is twice as thick as AB. So, you know, this is like a double and this one is a double. So what I want to do here is go ahead and find the lengths. So let's start with the length AB. So difference in x's squared plus difference in y's squared and then square rooted. So AB is 4 root 2. AC, again, very much the same thing. So 5 minus 1 squared plus minus 2 squared. So that's going to be 2 root 13 in size, and then AB, AC, so we just need BC left. And so let's go 3 minus 5 squared plus 6 minus 2 squared, and that's 2 root 17. So we've got our lengths. Let's look at the midpoints of each of these lines. So the midpoints of AB is going to be, again, adding them up. So minus 1 plus 3 over 2 and 2 plus 6 over 2, which is going to be 1, 4. Now for AC, we've got minus 1 plus 5 over 2, and we get 2 plus minus 2 over 2. So that's going to give me 4 over 2, which is 2, and 0 over 2, which is 0. So this is AB's midpoint, this is AC's midpoint, and now we're looking at BC's. So B to C, so 3 plus 5 over 2, 6 plus or minus 2 over 2. So this final one is BC, so 8 over 2 is 4, and 4 over 2 is 2. So now we've got the midpoints as well. So let me just double line everything that we're going to need. Now let's get back to this times 2 business. It's twice as thick. That's what it says, isn't it? Twice as thick. And it's very easy here to kind of just multiply them by 2. And that would be fine if we went from something flat that was then twice as thick. But this is a circular wire. So if I've got a circle, if it's now twice as thick as the original, then it's not going to be twice the area, is it? Because it is an area. So if this is in the ratio of 1 to 2 in terms of, like, say, a length, then that's in the ratio of 1 squared to 2 squared, or better still, 1 to 4 in terms of its area. Okay, another way to think about it is, giving it a value. If the radius on this one was 1, the radius of this one is 2, but the area is pi r squared. So we've gone from a 1 squared to a 2 squared. Okay, so it's now 4 times as big. So this is just something that we need to be kind of aware of. So looking at this, the ratio now is an area of 1 to 4 as we switch in the double length. Okay, so if I rub out these times 2's, because they are more confusing now, aren't they? And we're looking really at a times 4. So AB is normal size, so 4 root 2 times by its 1, 4, plus. And then AC and BC are the ones that are twice as thick. So we've got now 4 times 2 root 13, and that's 2, 0, plus 4 times 2 root 17, and that is 4, 2. And that then is going to equal, 67.486. So all I've done here is add these three together. Okay, and I'm going to store this in my calculator, and of course it's X bar, Y bar. And that gives me 195.285, carries on. This is obviously now before I've divided by my 67.486, etc. Then we got 88.597. So looking at my final answers, we've got 2.89 and 1.31 for my X and Y coordinates there. So the centre of mass is 2.89 and 1.31 to 3 significant figures. So we've got a mobile. Now, it's obviously not a mobile phone. This is like a mobile as in like a child's mobile. It's like, you know, something that might hang above a cot to entertain a child, a baby. Anyway, so it's made from two different flat materials attached at one edge, should really be, rather than end. Some bad grammar there. The mobile is modelled as a square lamina and a isosceles triangle. It's suspended from B and hangs freely in equilibrium. Find the centre, blah, blah, blah. So first, we need to find the centre of mass of this shape. Okay, so the centre of mass of the square will be nice and easy, isn't it? You know, it's going to be right in the middle here, which is 4 across, 4 up. And of course, you know, this one is going to be something similar. So we're going to go, you know, kind of, this is all from A. You know, and if I look at the triangle, we'd have B is at 0, 8, isn't it? C, well, come back to C. Let's do D is at 8, 8. And C, well, it's at 4, but I need to work out that height. So quick sketch of that triangle. It's 5 and 5, that's 8. Split it up, so that is 4. So all I need to do is the square root of 5 squared minus 4 squared, isn't it? Which is obviously 3, recognising it's a 3, 4, 5 triangle. That means the y coordinate must be, almost put 9 there. It is 11, isn't it? Because it's 8 plus 3 is 11. Let's get rid of this and work this out. So we've got 0 plus 8 plus 4 over 3. And 8 plus 8 plus 11 over 3. So that gives me 12 over 3, which is 4. But we knew that because, you know, line of symmetry here, isn't it? All the way down. And 8, 8 and 11 is 27. Over 3 is 9. So we've got 4, 9, which is really nice. Now we need to kind of look at the actual masses. So we've got the two here for our square and our triangle. So square is 20 grams per centimeter squared. So let's do that. A, B, C, D. So its area is 8 by 8, which is 64. We want to then times that by 20 grams per centimeter squared. So 1280 grams. B, C, D. So the triangle is, it has a base of 8, doesn't it? So it's half times 8 times 3. So 12 times by 60. So 720 grams. And looking at my total here, 2000 grams. Now, should be quite straightforward from here. So 1280 times by 4 plus 720 times by 9 equals 2000 times by, x bar, y bar. Now, in terms of the the x ones, we didn't really need to work it out. Look, that's 4, it's quite clearly symmetrical. It's definitely going to be on the 4. So, I can quite comfortably jump straight in with the x as being 4. No real working out needed there. Let's work out the y one though, and that gives me 5.8. So that's my centre of mass here. So 4 across, we know that's on this dashed line, don't we, that middle one, and 5.8, so say somewhere like here is my centre of gravity, centre of mass I should say, apologies there. We're suspending this from B, so we've got to go through B, so I'll draw a nice big line through B there. Now, the question asks for the acute angle it makes with AB, so it's this angle here. Okay, obviously I can, turn it around nicely on mine so you can see it hanging. That's what it would look like, but don't need to be able to kind of solve this. So let me just kind of pop that back. There. So let's go ahead and work these out. So we got this triangle, haven't we? We know where G is, and because of that then we can easily work out this angle here, isn't it? B, G, we know that G is at 4 across and 5.8 up, and we know that B is at 8 up, isn't it? So 8 minus the 5.8 there, and there is my angle. So I want tan theta is 4 over 2.2, isn't it? The 8 minus 5.8. And that should give me 61.2 degrees there to 3 significant figures. So I think part A was quite straightforward. Now, for part B, we've got a mass of 500 grams added in at point A here. So 500 grams added in there. Now, if I think of the original, so the original was 2,000 grams, and it was at 4 and 5.8. We've now got a 500 gram one. It's added in at 0, 0, because we took everything from 8, didn't we? But this is now 2,500 x bar, y bar. So in terms of our new centre of mass, our x is at 3.2 and our y is at 4.64. So in terms of these, now we're just around, say, here, just slightly different to before. Okay, and it's still obviously hanging in the same position. Well, not the same position, but from the same point, certainly. But so I need to do my new G through my new through B. And I've got this here. So again, it's very much the same as what we did previously. We've got this triangle. It's very straightforward here. We've got a new value of G, so I'm going to call that G2, still B there. And the distance across here is 3.2, and then this distance is 8 minus 4.64. Let's call this alpha. So tan alpha is 3.2 over 8 minus 4.64. And that gives me 43.6 degrees to 3 significant figures. And that's the end of this video. Hopefully you found this one useful as well. If you did, hit a like. Don't forget to comment down below and hit that subscribe button.